Students, in this video, we're going to go ahead and go over how to use the molarity formula. So I'll share my screen again. We're going to be on page 6 in the packet. Now, molarity is a sign of concentration. It's telling us basically how much stuff is dissolved in our solution. Molarity calculations are going to be really important when we work with any kind of solutions in a chemistry lab, because we have to be able to figure out that quantity, the mole relationship between, our reactants, or between our reactant and our product, or something to that effect. So we have to use the molarity formula in order to determine how much solute was dissolved in our solutions, okay? Now when you look at your formula here, molarity, which is going to be represented by a big M, okay? So that's going to be our unit for molarity. And the formula is molarity is equal to moles of solute over liters of solution. We need to make sure that this is moles on the top. We cannot put grams. We have to have moles on the top. We're going to have liters on the bottom. So when you're looking at the molarity, that big M, the higher the molarity means that it's more concentrated solution. If you have a lower molarity, it means that it's more dilute because you don't have as much stuff, as much solute dissolved into your solution. You have to have liters on the bottom here. So if you need to convert between milliliters and liters, you're going to move your decimal point 3 times to the left in order to get it into liters. Now, when we were doing our percent mass and percent volume calculations, we ended up having to add our solute and our solvent together to get the solution for the bottom of that formula. We do not do that with molarity, okay? Because when we're looking at the molarity, we're going to have grams of our solute and we're going to have the volume of our solution or our solvent. We can't add those together. We can't add grams to liters. So we are only going to be focusing on the volume that's given to us in the problem to put on the bottom of that calculation. Okay, so let's take a look and see how this goes. So example 7 on page 6 here says that a salt solution has a volume of 0.250 liters and contains 0.70 moles of sodium chloride. What's its molarity? So molarity is equal to moles, so 0.70 moles over liters. So we have 0.250 liters. So in order to solve, we just have to divide on this one. We always base multiplication and division sig figs over whichever one has the fewest amount of sig figs, in this case 0.70. So our answer is going to be 2.8 and our unit is big M. So that's how we would record our answer here for example 7. For example 8, it says, what's the molarity of an aqueous solution containing 40 grams of glucose and 1.5 liters of solution? Now remember, our formula for molarity is moles over liters. We can't use grams. So if we're given the grams, we have to convert from grams into moles. So this is just a simple gram to mole conversion. We give you the molecular mass here, so 180.18 grams of glucose, and that's equal to 1 mole. And then we can go ahead and solve. So I've got 40 divided by 180.18. So that's going to be 0.222. Now that I've got my moles, I can find my molarity by taking my moles and dividing it by liters, 1.5 liters. And so I usually use my unrounded mole calculation from the calculator when I divide so that I don't end up rounding the sig figs until the very end. I can only have 2 sig figs here because of that 1.5, and so I would record my answer as 0.15 mole, big M, molar, okay? Next one. A saline solution contains 90.0 grams of NaCl per 100 milliliters of solution. What's its molarity? So remember, molarity is moles over liters. I'm going to have to move my decimal point 3 times to the left here to get this into liters. And I'm going to have to convert my 90 grams of salt into moles. So I have to put the molar mass of salt down here, which is 58.44 grams of salt. And I have 1 mole of salt up here on the top. So when I calculate here, I'm going to get 1.54 moles of NaCl. And now I can go ahead and find my molarity by taking those moles and dividing it by the liters. Let me undo that because there's only one sig fig here. And so my answer would end up being 0.154 big M. However, because my 100 milliliters only had 1 sig fig, I can only have 1 sig fig for my answer, and I would have to round this to 0.2 molar. And that would be my answer. Last example here, how many moles of solute are in 1.5 liters of a 2.20 molar solution of Na2SO4? So here, I've got my molarity, 0.20 molar. I'm trying to find my moles, which is up here on my top. That's my X. And I've got my volume here, 1.5 liters. Now, in order to solve for my moles, my X, I'm going to have to multiply my molarity by my liters to get X by itself. So I've got 0.2 times 1.5. That means I've got 0.30. So that's the answer for the first question, 0.30 moles of Na2SO4. Now, in order to find out how many grams, I just have to do a simple multigram conversion. So 0.30 moles of Na2SO4 times 1 mole down here on the bottom, because I need to put my molar mass up on the top. And let me go ahead and calculate my molar mass, 22.99 times 2 plus 32.06 plus 64, 4 oxygens, 142.04. And that means that I've got, I only get 2 sig figs, so I'm going to round my answer to 43 grams of Na2SO4, and that is my answer. All right? So what I want you guys to do is do these problems 11 and 12. I think they're on page, I'm not really sure now, 7, I think. You can omit number 13, so don't worry about doing number 13. It's not worded the best. And you guys can check your work on the answer key. And if you have any questions about doing any kind of molarity calculations, just let me know. Bye.